Assalamu alaikum, dear student. Today I will discuss the thin layer chromatography. In this video, I will explain what is thin layer chromatography, different types used for TLC, and then practical procedure how we can perform a thin layer chromatography practical. I am Dr. Tahir Mahmood. Now let's start. The content of the video is first what is chromatography, then I will discuss different classification of the chromatography, then introduction to our main topic thin layer chromatography, its major component, and explanation of the procedure to perform TLC practical, and visualizing technique which are used for TLC. First, what is chromatography? Basically, chromatography is a separation technique. Here we have a mixture of the substance. We can separate into its individual component, as we have seen yellow, red, blue, black. So we have separated the mixture into their individual component, and after that we will analyze that component, identify, purify and quantify. So this is called a chromatography. Here I have written a definition. It is a technique for separating mixture into their component to analyze, identify, purify and quantify. That is called a chromatography. Basically, chromatography first introduced in 1903. Michael Sweat was the scientist who first used this technique for the separation of colored substance, and that is why he used the word chroma mean color and graphy mean writing. Basically that are Greek word chroma and graphy. So chromatography is derived from that words, and Michael Sweat used first time for the separation of a colored substance. And for the chromatography, different words are used. Differential. What is mean differential? Mean showing a different affinity. It is also called distinctive. Then affinity word are used. Natural attraction or force between two things. Mobile phase word are used in chromatography. They are maybe gas, liquid that carries the component. And stationary phase, the part of the apparatus that does not move with the sample. Mean mobile phase separate the sample by moving and it carries the component. So these are different terminologies which are used in the definition of chromatography. So what are the classification of chromatography? First, based on the interaction of solute to the stationary phase, divided into adsorption chromatography, ion exchange, partition, size, exclusion chromatography. In this four type, they are based on the stationary phase. Which type of stationary phase we have used? Solid or liquid. Based on the chromatographic bed shape, which type of bed we have used? There are two-dimensional and three-dimensional according to their bed shape. And based on the physical state of mobile phase, liquid chromatography, supercritical fluid and gas chromatography. Mean what are the type of phase we have selected for mobile phase. And adsorption chromatography is further divided into column chromatography, thin layer chromatography, and partition chromatography, paper chromatography. There are also other classification of chromatography also used. Now, as TLC based on adsorption chromatography, so we will discuss what is adsorption. Adsorption chromatography is probably one of the oldest type of the chromatography that are used. It utilizes mobile, liquid or gas phase that move on the sample component on the stationary phase where they get adsorbed. So stationary phase are solid here mostly, so that is why it is called adsorption on the solid surface. Adsorption chromatography basically involves the computation of the component of the sample mixture for active sites on adsorbent which are formed in molecule due to cracks in the adsorbent or edges. So these cracks or edges are used for the separation of the component by using adsorption chromatography. So now I come on the topic that is thin layer chromatography. It's a type of adsorption chromatography. It is used to identify different components of the mixture. This technique of separation is based on solid liquid adsorption. Means solid is the stationary phase and liquid is the mobile phase. Here in this diagram, as you see, the liquid phase, this is stationary phase which is solid, and this is the mobile phase which is liquid, which separate the component of the analyte into different individual components. So this is the phenomena of separation of mixture. Different words are used as a synonym for the TLC. Mean there are also similar words that are used instead of thin layer chromatography. It is also called open column chromatography, planar chromatography, strip chromatography, spread chromatography, drop chromatography, surface chromatography. These are also the name used instead of thin layer chromatography. So these are also called TLC. Now what is the principle of thin layer chromatography? Basically, this technique plays polarity interplay between sample and the other substances, that is the solid, which are mostly stationary phase and the mobile phase. So on the basis of polarity, we will separate the sample from the stationary phase. In this technique, the sample to be separated first become adsorbed on the surface of the solid phase through polar interaction, and after that polar substances are adhere more strongly than less polar ones, and the mobile phase come in and sweep across the stationary phase competing for the sample. So which is the less polar come first and then others. More polar solvent, more its capacity to carry component of mixture with it. Different component of different polarity travel at a different rate. So I have a diagram. So this is a TLC plate and these are the sample which have different component. Sample first adsorb on the solid phase. Here this color is indicated for sample mixture and pink color is indicated for the stationary phase on solid spot. So after that we will use eluent. Eluent is the solvent which separate the component. So eluent will travel in a direction from lower to upward, and after that red component have more affinity with the solvent, it will travel fastly, and black color have more polar and it have more adhere with the stationary phase, so it remains backward. So they will separate on the basis of their polarity, and as if this way we can get a different component, less polar, more polar. Here I have also taken a video component orange and green. As you see that this is a stationary phase and this is our mixture sample. So orange have more affinity towards stationary phase so it will move slowly, and green have less affinity with the mobile, more with the mobile phase and less with the stationary phase, so it will move faster. So it will fast and come first, and this brown color will remain at the lower way. So this is affinity of the stationary phase show, and it have more affinity with the brown color, and it is the affinity with the mobile phase, and here green color have the affinity with the mobile phase, and it will fast move with the mobile phase. On this way we can separate the mixture by changing polarity. So there are two classes of TLC, mainly based on the phases. Normal phase, in which stationary phase is more polar than mobile phase. So we can use different types of phases depending upon the separation method. And other is reverse phase. In reverse phase, when mobile phase is more polar than stationary phase. Here mobile phase is more polar, here stationary phase is more. So first we use normal phase, and now reverse phase is more prominent and mostly used as a separation technique. For performing a TLC, what we have to need: adsorbent, binder, eluent, TLC plate, chamber, sample solution, filter paper, capillary tubes, visualizing reagent, lamp, UV, time, chemical, and then some institute. So what is adsorbent? Adsorbent basically, as it is adsorption technique, so first we have to see what is adsorption. Adsorbent are coated on the sheet of glass or plastic to make stationary phase. Here I have taken a diagram. Here this is a plate on which we adsorb some silica, alumina. Here is the side view and it is the front view. So we will first make adsorbent on our station, which is here. And commonly used adsorbent are silica, alumina and cellulose. These are most commonly, three are used. Other are also used, that is magnesium silicate, calcium silicate and activated charcoal, but these are less commonly used. So first we have to select the adsorbent, and after adsorbent chemistry, what is silica gel? Most commonly used adsorbent, and it is also used for all type of the separation. Due to silica gel polarity, non-polar component tend to elute first. This is the structure: silicane with oxygen silica and OH. So this is the linkage of SiOS and SiOH. These are the linkages in the silica gel, and it is most commonly used for TLC plate preparation. So non-polar component here elute first. Second one is the alumina. Similarly, its selectivity data for the silica available with different 3 pH ranges. It have acidic nature, neutral, basic. After its activation, we can change it into acidic nature, basic or neutral. Popular application include the separation of alkaloid, aliphatic compound, aromatic, steroid. These are the components which are mostly used for the using alumina. Then cellulose can be unmodified or positively charged at acidic or neutral pH, and hence it is frequently used for the partition of hydrophilic molecules, and it is mostly used for bimolecule exchange of ion. Adsorbed water alcohol can be retained by interaction with the hydroxyl group. So it is mostly used for the purpose of ion exchange chromatography. And after that we have to use a binder which binds these adsorbent on a TLC plate. Some adsorbent do not bind well to TLC plate, so we use some inert binder, that is plaster of Paris are mostly used as a binder. Gypsum, polyvinyl alcohol, PVA is also called, that adhere adsorbent on the plate properly. So it is work like a glue, mean adhering property for the adsorbent. They are mixed along with adsorbent and then slurry is made, and these slurries are applied on the plate. And after that, eluent or mobile phase are selected for the TLC plate. Selection of solvent is the most important parameter for efficient TLC plate separation, and basically depends upon which kind of the substance we wanted to separate and what are the type of adsorbent of the TLC plate. So by looking these substance nature and nature of the adsorbent, then we will select a suitable mobile phase which we will use for elution. The general procedure is to match polarity of the solvent to that of the substance being separated. Mean if they have same polarity, then they are easily separated. For example, polar substance, we will want to prefer polar solvent, and for less polar we will prefer a non-aqueous solvent, because these are non-polar or less polar in nature. So for the selection of mobile phase, the nature of the substance is very important. And after that, different types of TLC plates are available in market. Majorly they are the three types: glass, aluminium and plastics. But they have certain advantage and disadvantage. First, glass plate, high heating stability, we can heat it at high temperature, high chemical resistance and transparent. So these are the advantages if we use a glass plate, depending upon the practical nature. The next inconvenience, it is thick, fragile, impossible scissor cutting, we cannot cut depending upon the size, cannot be stored in lab notebook. So these are the problem if we use a glass plate. High weight. And next is the aluminium plate. They are thin, low weight, high heating stability, fragility is low and easy to cut, can be stored in a lab notebook. So these are the advantages if we use aluminium, but low chemical resistance and opaque. Third one is the plastic, which are mostly used and easily available. So what are the advantages and inconvenience? Low fragility, possible scissoring cutting, high chemical resistance, can be stored in lab notebook. Only one inconvenience, it is opaque in nature. So its medium weight, heating stability is also at 175 Celsius. So these are the three types of plate which are mostly used for TLC, and we will prefer plastic plate normally. And after that, visualizing reagent. If our component are colored, then no need of visualizing reagent. But if our substance which are separated are colorless, so for that purpose we need some visualizing reagent to identify the separation. So any fluorescent or quenching compound is used which are visualized under UV lamp, and there are certain other spraying reagent are available which can be used for the visualization. What kind of visualizing reagent? I have choose 3 or 4, and there are number of visualizing reagent available. First, vanillin in sulfuric acid. Almost all organic compound except some alkaloid give distinct color of the band with this reagent. So it is mostly used as a visualizing reagent. And after that, iodine. The plate are placed in iodine chamber containing iodine crystal. Compound absorb iodine and appear as a brown area on a faint yellow background, mostly used for detection of carbohydrate, starch. Ninhydrin is used mostly for amino acid. Aniline phthalate, it is also called aniline phthalate, for detection of sugar component. So I have chosen only 4 number of visualizing reagent are available which can be used. Then TLC chamber, basically developing chamber, that the fancy name of a beaker or jar having a lid. Basically it's shaped like a beaker, but it is called a chamber, developing for the TLC plate. The Elution and TLC plate are kept it in for a development, and after development filter paper. What is the purpose? Usually filter paper which is wet with the solvent is placed around inside wall of the chamber, and the lid is closed for some time before performing analysis, because in this way all the environment are saturated with the mobile phase, so it will get a better separation. So we use a filter paper. Reason for chamber saturation: if we do not use chamber separation, then certain problem will arise. First, uniformity will be disturbed. A plate is introduced in such chamber, it gets soon preloaded with solvent. Less solvent required to travel distance because they are already saturation point. Lower RF value, large quantity of solvent is required for given distance, because when they are not saturated, so some solvent is used for saturation, so it required large time and it will give very low RF value. So these are the problem if we use not a filter paper before start of the practical. Now preparation of things to be used in TLC procedure. Now we will go for the procedure. First we will to prepare a slurry, and after slurry preparation plate will be prepared and capillary spotter prepare. These three things we will prepare. Now I will discuss the procedure. First, slurry preparation. For the slurry we use adsorbent, which I have discussed. Alumina, silica, cellulose may be used, and after binder like calcium sulfate, polyvinyl alcohol, and then distilled water. Shake well for the 2 minutes, which will prepare a slurry. So how will we prepare? I have taken a video. We will take about 5 gram of the silica gel in a mortar pestle and add a distilled water in it, and after that we will make a clear and proper mixture and a homogeneous. When a homogeneous mixture is formed, then we will stop it. So our slurry will be prepared, and after preparing the slurry we will prepare a TLC plate. Pouring, dipping, spraying and spreading. These are the 4 different steps taking place for the preparation of the TLC plate. First, for the pouring we will check. Here I have taken, it should be a smooth pouring, and here you will see that there is not a proper pouring, so it is not a good TLC plate. So TLC plate will be prepared properly and should be oven dried, and after we will prepare a slurry and pour it into a glass or plastic plate, and plate is subsequently tipped backward and forward to permit slurry to spread uniformly. If it is not uniform, then it will not give a good result. So pouring is very important to prepare a homogeneous uniformity in a plate. And after that, dipping. The technique that is used for small plate by dipping 2 plates at a time back to back in a slurry of adsorption. Plate are separated after removing from slurry and later dried. And after dipping we will use spray, and after spraying spreader will be used. Nowadays, what are the properties of spreader? This is the best technique where a spreader is used. Glass plates of specific dimension are stacked on base plate. Slurry after preparation is poured inside the reservoir of the TLC separator. Thickness of the adsorbed layer is controlled by using a knob in the separator, and then separator is rolled on the plate only once to give a uniformity. Capillary spot preparation, which are used for the sample loading. So it is made from a glass tube into a flame, and we will make a capillary which we will use for the spot. First, cutting the TLC plate. After preparing, we have to use different types of TLC plate depending upon which kind of separation are needed. We will cut into 1.4 into 4 centimeter plate or larger depending upon the nature of the substance of the sample. Then lightly score has glass side, not the silica side, with the blade or glass cutter. It should look like picture below, which obviously cut in the glass. Now carefully pick up the plate and break it by bending it with your hand away from you. Glass will easily break along a smooth edge if scored. Be very careful, but you must use enough force to break the glass. So this is the cutting procedure for preparation of the TLC plate. And now we will have to mark the TLC plate. Here I have taken a diagram. Draw a line with a pencil about 5 cm from the bottom. And after making the line, we will use a pencil, that is lead pencil. If we use any other ink pencil, then they may be cause problem because they will also separate with the solvent. So if we use lead pencil, it contains graphite which will not move with the solvent. So write very gently, otherwise you will scrap off the screen because it is coated with adsorbent. So care should be taken. Now preparing the solvent which are used for the practical. Depending upon the nature of the substance, polar, non-polar, we will prepare different types of solvent. Now solution or sample solution. Take a starting material for your reaction and dilute it into small well with ethyl acetate. TLC is very sensitive, and even at 1% solution of your compound is plenty. Mean do not add too much amount of the sample. Only small amount of the sample will give better separation. So dilute solution is mostly used. And after preparation, activation of the plate is very important. And what is mean by activation of the plate? Sample is loaded on the plate, and after that TLC plate is heated at 110 degrees Celsius for several hours, and this is called activation. Here this is an hour we have placed the TLC plate at 1 degree centigrade in oven, and that procedure is called activation. Basically it will remove the water from the sample and other polar liquid, so it will give a very good result. Otherwise interference will cause in the sample. So activation of the plate. After that, spotting. Here we will use a different spotting. Here I have used a video. We have a component standard. We will use standard and sample by using a different types of capillary tube. So it is better to use separate dropper for the separate sample. So these are the two videos which show how we apply a sample on a TLC plate. Usually 1 centimeter or less distance is required. So after spotting, place the plate in a chamber. Here a video I have taken. We have do not use a hand by using a forceps, which will place a TLC plate, because if we use a hand then it will may cause contamination. So it is best to use some kind of a tweezer to hold the plate. So the solvent is already in the chamber, and after, plate should be placed upright, slightly inclined against the wall of the container. Solvent in chamber should not touch the sample, so cover the container and wait for the elution to proceed. And after elution technique, different types of elutions are used, because different type of solvent require different times. So we have to wait different 5 minutes, 10 minutes for the elution, and then ours develop. So this is the developing method. Here the mobile phase move with the sample and separate the component, and in this diagram I have shared how elution will be take place. It is elution or developing technique of the TLC plate. Various methods are used to develop a chromatogram: ascending, descending, two-dimensional, stepwise, multi-steps. So these are different elution or developing technique used in paper chromatography and TLC plate also, which is also one-dimensional, vertical. So normally we will use ascending or descending or one or two dimensional. So first, what is ascending development? Here this is an ascending. It is convenient development. Solvent flow against gravity because of capillary tube. Here the solvent is in the below side and it will move upward, so it is against the capillary tube. That is called ascending. Here this is descending. The solvent move with the help of gravity. So ascending and descending. In which one, ascending, the solvent flow against the gravity, while in descending the solvent move with the same direction of gravity. Two-dimensional, first we have separate the component by eluting in one direction, and after that the plate are changed, dried, and then 90-degree change, and then they are separated again. So it is called two-dimensional. Means first dimensional from one side and then other two-dimensional. It is used when the RF value of the component are very similar, and then we use two-dimensional chromatography. Stepwise, large size plate is used done when component distance is long. First, one mobile phase is allowed to travel 15 to 18 centimeter, stop and dried. Then the same plate is kept in other mobile phase and development is done. Means stepwise. First one solvent, then the plate is changed, second solvent, third solvent. So that is called stepwise development. Multiple development used to separate complex mixture. Development is carried more than one time in the same solvent and in the same direction. That is called multiple development. So these are the developing technique used for the separation of a component. Mark solvent front. When we will develop the solvent, then after that we will make a solvent front by using a lead pencil with the help of a mark the pencil the highest place of the solvent reach. That is called the solvent front. Mean where our solvent will reach and after further do not move. That is called the solvent front, and we will mark it with the help of a lead pencil because it is used later for the calculation of RF value. Do not touch the silica with your finger again. And after developing, we will dry the plate. After marking the solvent front, we will use, and simple drying method is use simple dryer, which is used for the drying, so it will not damage the plate, so small heating is used. And after development, we will use visualizing technique. If our colored component, then we do not need any visualizing. If our color support are colorless, then we will use visualizing technique. Different visualization methods are available, but some are destructive and some are non-destructive. Iodine staining and UV lamp are commonly used for this purpose. So first, UV lamp. By shining the UV light on a special lamp on the plate. Here we have TLC plate, and after when we will fall a UV lamp, then you see different spots are appear, which are otherwise do not appear. So it will show where the sample are separated. And after that, UV light will stop from the shining on the plate, the spot will disappear. So for checking the sample, we will mark the dark spot by using a pencil, because when we will UV light off, then we will not see any kind of spot. So we will mark the spot by using a pencil. So when we light off, then we will know that where component are present. So these are the visualizing technique. And after that, we will calculate RF value, that is called a retardation factor or relative flow. And how we can calculate RF, I have used again a video. So this is the baseline from where we have started the practical, and after that these are the components which are separated by using the solvent, and these are the mark which we are used, that is called a solvent front. As you see, it is 6 centimeter, and these are the different 4 centimeter, 2.1 centimeter, and RF mean distance traveled by the component divided by solvent front, as in 4 by 6, here 2.1 by 6. So that is called a retardation factor, and here I have used a scale to calculate, and you know easily by this video. Use a ruler to measure the distance to the solvent front and to the middle of the spot. Here you can see this is the spot, and we have marked it on the middle. Its value is always between 0 to 1, because we have to divide with the solvent front, and always solute will be behind. So its value cannot be greater than 1. By calculating the RF of the known compound, you can identify them on a TLC plate, because we have used standard also. Different component will almost always have different RF value, making them easy to distinguish. RF value is used to identify unknown substances, but RF value are impossible to reproduce from one experiment to another due to change in experiment condition. So far, comparison of the compounds should run simultaneously on the same plate. Means we will run sample and a standard simultaneously to identify the unknown component. RF value are always less than 1, as I have already told that the distance traveled by the solvent front is always greater than the distance traveled by the solute. So basically it is a ratio, so it is not greater than 1. The spot and the solvent front travel close together, hence unreliable, occur when mobile phase is too polar. So they will reach at the solvent front, so we will different to distinguish between them. There is almost no separation occur when solvent is non-polar enough for the sample. Then they are not properly separate, so we will not properly calculate the RF value of the substance. So that's all from the Thank you very much. Allah Hafiz.